Let's start with the objectives of this tutorial. Interference of waves means a circumstance during which the two waves gets overlap. In this article we will discuss about various wave interference examples. Wave interference examples occur in the following: Lightwave interference, radio waves interference, sound wave interference, water wave interference. Lightwave interference. Interference is a happening under which two light waves collide. And after the collision, their amplitude becomes either greater, lower, or remain the same as the original waves. Interference can be anywhere around the world. However, indeed, we do not see interference patterns all around. In most common real life, interference of light can be seen. This happens because light waves, although they generate everywhere, get reflected from the reflective surface. Due to this, the light waves are randomly found everywhere. But for interference to occur, it is necessary that the light waves are of the same amplitude or, say, in the same phase. Which means they should be coherent sources. And as light waves around us are not generated from a single source, interference cannot be seen everywhere. Interference of light waves are of two types: constructive light wave interference, destructive light wave interference. Constructive light wave interference. The two light waves are in the same phase in constructive light wave interference. Due to this, their crest and trough get to add up, and their amplitude is increased. Destructive light wave interference. In destructive interference, when two waves interfere in each other's paths, then it results into a mismatch, which means their crest and trough are cancelling out each other. Here crest of one wave falls on the trough of the other wave and vice versa. Due to their amplitude is decreased. Radio waves interference. Radio waves interference happens when two radio waves have a collision in their pathways. Radio frequency waves interference can be understood as a circumstance under which, due to the conduction or radiation of radio frequencies, energy S causes a formation of sound from an electrical device that interferes with the function of the device aside from it. Due to radio waves interference, there is also an interruption in the functioning of the satellite. Like all other wave interference, radio wave interference has its implications. Radio wave interference causes interference in the normal functioning of electrical devices. There are various causes behind interference of radio wave interference. A few of them are as follow: natural phenomena like lightning strikes, static electricity, thermal shot, solar radiation from the sun, hurricanes in tropical or temperate regions can alter electromagnetic radiations. They are causing radio waves interference. The second example is electrical or mechanical devices, like electric light bulbs, personal computers, laptops, gaming devices, mobile phones, and many more. Sound wave interference. The circumstance under which two sound waves collide is known as the interference of sound waves. Sound waves are also similar to any other interference of waves. Sound wave interference is also of two types: constructive interference in sound waves, destructive interference in sound waves. Constructive interference in sound waves. Constructive interference depends upon how the waves are going to interact. If the two sound waves collide in their path in such a condition, they complement each other. Complementing each other shows that during a constructive sound wave interference, the top of one wave lies on the top of the other sound wave in its path. And simultaneously, the depression of one sound wave falls on the depression of the second sound wave in its path. Due to this, the amplitude of the resultant wave increases and is in the same phase. Constructive sound wave examples is an auditorium. Destructive interference in sound waves. Destructive interference depends upon how the waves are going to interact. If the two sound waves collide in their path in such a condition, they degrade themselves. This means during a destructive sound wave interference, the crest of the first wave falls on the trough of the second sound wave. And consequently, the depression of the former sound wave falls on the top of the later sound wave. Due to this, the amplitude of the resultant wave decreases, and they get out of phase. Destructive sound wave examples are headphones. Water wave interference. Interference of water waves can be explained as a situation under which water waves originating from two-point sources collide with each other. Due to this, there is the superimposition of waves causing interference of water waves. For interference, the principle of superimposition is to be implied. According to this, if two or more waves are traveling in the same medium, the average displacement between the two waves is the vector sum of the displacement caused by them individually. There are two types water waves interference. Constructive water wave interference, destructive water wave interference. Constructive water wave interference. The constructive water wave interference happens when two waves of the same frequency add UPS to increase their amplitude. When the two water waves collide in their preceding path in such a condition, they complement each other. This implies that a constructive water wave interference occurs when the top of the former wave rests on the top of the later water wave in the path of interfering each other. And consequently, the depression of the former water wave lies on the depression of the later water wave in their path. Due to this, the amplitude of the resultant wave increases and is in the same phase. Destructive water wave interference. The destructive water wave interference happens when two waves of the same frequency cancel out, and their amplitude decreases. In destructive water wave interference, the two water waves degrade themselves when colliding in their path in such conditions. This means during a destructive water wave interference, the crest of the first wave falls on the trough of the second water wave. During this time, the depression of the former water wave lies on the top of the later water wave in path. Due to this, the amplitude of the resultant wave decreases, and they get out of phase. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.